So in this problem, we need to show that the 3 points A, B, and C form the vertices of a right-angled triangle. So let us begin. So we'll begin by considering a triangle A, B, and C. Now A has the coordinate given by -2, 3. B has the coordinate 8, 3, and C has the coordinate 6, 7. First, let us find out the length of each of the side. All we have to do is use the distance formula. So here the distance formula is specified. Let's say we have 2 points, point A and point B. The coordinates are given to us. If we join point A and B with the help of a straight line, then the length can be obtained by using this particular formula, where we have AB equals to square root of, here we have x2 minus x1 whole square. x2 minus x1 means that's the difference of the x coordinate, and this is added to y2 minus y1 whole square, and y2 minus y1 represents the difference of the y coordinate. Now let's apply this particular formula. So we can find out the length AB first. So AB is going to be equals to, we'll take the square root. Underneath the square root, first we will take the difference of the x coordinate. So we'll start with B, the x coordinate of B, so that's 8. And from here, we're going to subtract the x coordinate of A. So we have -2. So negative from -2 will make it positive. We have 8 plus 2 squared. Added to, now we have the difference of the y coordinate. So we'll have 3 minus 3. So that's going to be squared. This will be equals to, so 8 plus 2 whole square, that's 100, that's 10 squared. So 10 squared plus 0 squared, and this gives us a value equals to 10. So that means the length of AB is 10 units. 10. Now we'll find out the value of BC, or the length of BC. All we have to do is first take the difference of the x coordinate. We will do 6 minus 8. So 6 minus 8 whole squared. This will be added to the difference of the y coordinate, which is 7 minus 3. 7 minus 3 whole squared. This will be equals to, so we have 6 minus 8, that's -2. -2 squared will be positive 4. Plus 7 minus 3, that's 4. Square of, then we have 4 squared, so that's going to be 16. So this will be equals to square root of 20. Fine. Then we find out the value of CA. So CA is going to be equals to, we'll take the square root. Underneath the square root, we do -2 minus -6. Whole squared, added to 3 minus 7, over 3 minus 7 squared. So this will be equals to, we have square root of, so -2, -6, that's -8. Square of -8, that's going to be 64. Plus we have 3 minus 7, so that's 4. Square of 4 is going to be 16, and this gives us a value square root of 80. Now clearly, let's do one thing. Let's square each of the lengths. So we have LB squared, that's going to be 10. We have length of BC squared, so that's going to be 20. And then we have CA squared, that's going to be 80. Now clearly, this is going to be 100 squaring AB, because we have a 10. Now we can see here that AB squared is simply equals to BC squared plus CA squared. So that means AB is actually the hypotenuse. So AB is the hypotenuse, and then we have the right angle, which is right angle at C. So AB has a length of 10 units. AC we found that square root of 80, and CB or BC, that has a length of square root of 20. So this is indeed a right angle triangle, because it is following the Pythagoras theorem. Hence ABCD are the vertices of a right angled triangle.